Welcome to lecture 8. My name is Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay, Mumbai, India. The name of the course Geosynthetics Engineering in Theory and Practice. This is Module 2, Lecture 8, an overview of geosynthetics. I will now focus the recap of the previous lecture. We cover function of geosynthetics, then geosynthetics functional application, multiply function of geosynthetics, design of geosynthetic, geosynthetic type and function, application and function of geotextile, design parameter and application of geosynthetics, and the correct choice of geosynthetics. Now, I will give one example, that is determine the properties of geosynthetics for highway design using the AASHTOM288 table. First of all, we should know the use of this ASHTOM288 table. Case 1 is strain of non-open geosynthetics used for filtration is greater than 50% and 65% in situ soil passing 0.0075 millimeter, severity under mild and severe serviceability condition. That means soil passing through 0.075 millimeter sieve under mild and severe serviceability condition. Case 2, strain in open geotextile used for separation is less than 50% under mild and severe serviceability condition. So, in this problem, first of all, case 1 will check that strain of non-open geosynthetic material is greater than 50% and 65% and it is under mild and severe serviceability condition. So, you remember that we will use that it is greater than 50% and 65% and under the mild and severe serviceability condition. Similarly, case 2 for the strain in open geotextile used for separation, it is less than 50% and under mild and severe serviceability condition. Now, I will go for the solution. So, the ASHTOM288 geotextile specification provide 3 different conditions for several applications of geosynthetics in various infrastructure of civil engineering. Case 1, severe serviceability condition. Case 2, typical serviceability condition where there is no site specific information, and case 3, mild serviceability condition. Now, look at this table, ASHTOM288 geotextile strength property requirement. What strength are required? There are class 1, class 2 and class 3. This is all geotextile class, and these are the property we require, that is graph strength, as per STMD 4632, strain seam strength as per STMD 4632, tear strength STMD 4533, puncture strength STMD 4833, brass strength STMD 3786, permittivity STMD 4991, apparent opening size STMD 4751, ultraviolet stability STMD 4355. And the class 1, you can see here that elongation that's less than 50% and elongation greater than equal to 50%. If it is a less than 50%, so this value, graph strength value 1400 Newton, shear strength value 1260 Newton, tear strength value 500 Newton, puncture strength 500 Newton and brass strength 3500. And you have to also calculate what will be the permittivity, apparent opening size and ultraviolet stability. Now, if it is a greater than 50, these are the value 900, 810, 350, 350 and 1700. Similarly, for class 2, if it is a less than 50%, if it is a greater than equal to 50%, these are the all values. And similarly, class 3, if it is a less than 50% and greater than equal to 50%, then you can have all these values. Now, you can see here very carefully, class 1 means severe serviceability condition and class 3 is mild serviceability condition. So, remember which is severe case in class 1 and mild is class 3. Next is the table 2 ASTO M288 geotextile subsurface filtration drainage property requirement for highway under drain. So, here the geotextile permittivity as per STMD 4491 in unit is per second, and you can see that requirement percent in situ soil passing 0.075 millimeter. It may be less than 15 or 15 to 50 or greater than 50. And case of class 2 permittivity as per STMD 4491, this value is 0.5, this if it lies between 15 to 50 then 0.2, if it is greater than 50 then it is a 0.1. And apparent opening size of geotextile STMD 4751, this unit is millimeter, 0.43 maximum average roll value and 0.25 maximum average roll value and 0.22 maximum average roll value. And ultraviolet stability also very important. This is as per test method STMD 4355 and that expressed in percentage unit. This is 50% after 500 hour of exposure. The next table 3, this is ASTO M288 geotextile separation property requirement firm strength subgrade. Now, geotextile may be permittivity, test method STMD 4491 and class 2, this is class 2, so requirement 0.02, apparent opening size STMD 4751 and this is in millimeter unit and requirement 0.60 maximum average roll value. Ultraviolet stability retained strength STMD 4355, that unit percentage, that is 50% after 500 hour of exposure. So, it depends upon what class, this is class 2 whereas this also class 2. Similarly, you can have there are many ASTO table specification. Now, we are solve the case 1 problem, that is filtration, and condition is that mild serviceability. So, we can determine the property from table 1 and 2. So, we can obtain the following property for non-woven geotextile material, that is Graf tensile strength is greater than equal to 500 Newton, strain seam strength is greater than equal to 450 Newton, tear strength greater than equal to 180 Newton, puncture strength greater than equal to 180 Newton, brass strength greater than equal to 950 kilopascal, permittivity greater than equal to 0.1 per second, apparent opening size which we say AOS less than equal to 0.22 millimeter, and EV stability greater than 50% of the 500, this Graf strength value, that is greater than equal to 250 Newton after 500 hour of exposure. So, we can see this table 1 and 2, you can see this is the table 1, and because it is a mild, so we have, and the elongation is greater than 50%, so we are considering this value, these are the value, Graf strength, then strain seam strength, then the tear strength, then the puncture strength, and also the brass strength. And this is for strength property of the requirement. Next is that what will be the permittivity, apparent opening size, and the ultrafall stability. As this is greater than 50, because 65% greater than 50, so permittivity is 0.1 per second, and the apparent opening size 0.22 maximum average roll value, and ultrafall stability STMD 4355, that is 50% after 500 hour of exposure. So, this way we have calculated and show that what will be the properties of the geosynthetics material requirement, and this is for mild serviceability condition. Next, if it is a severe serviceability condition, that means severe serviceability condition, that means we will follow up table 1 and table 2. So, from this table 1 we can obtain Graf tensile strength greater than equal to 900 Newton, strain seam strength greater than equal to 810 Newton, tear strength greater than equal to 350 Newton, puncture strength greater than equal to 350 Newton, brass strength greater than equal to 1700 kilopascal, and from the table 2 we can have permittivity greater than equal to 0.1 per second, apparent opening size, that is AOS less than equal to 0.22 millimeter, and EV stability is greater than equal to 50% of 900 Newton, because this Graf strength value is 900. So, 50% of the 900 Newton, that is greater than equal to 450 Newton after 500 hour of exposure. So, you can obtain this value from the table 1. I say that this is table 1 and this is in severe condition. So, and this value is greater than 50%, because greater than 50%. So, we have taken all this value, that is Graf strength, strain strength, tear strength, puncture strength, brass strength, etc. And also for permittivity we have taken that this is 0.1 and 0.22 of maximum average roll value. So, this way we have solved this problem, and this is for severe serviceability condition. This is case 1. Now, this case 2, separation, and this is mild serviceability condition. So, for the mild serviceability condition, and from the table 1 and 3 we obtain the following property of open geosynthetic material. That means Graf strength is greater than equal to 800 Newton, strain seam strength is greater than equal to 720 Newton, tear strength greater than equal to 300 Newton, puncture strength greater than equal to 300 Newton, brass strength greater than equal to 2100 kilopascal, permittivity greater than equal to 0.02 per second, apparent opening size AOS less than 0.60 millimeter, that is maximum average roll value, and ES stability 50% of graph strength, that is 800 Newton, that means greater than 400 Newton after 500 hours of exposure. Because this is a mild severity condition, remember, mild severity condition. So, graph strength you can say from table 1 and 3, you can see table 1 and 3, because it is the mild. So, this will be the class 3, and it is also less than 5, that is why we have taken this value. And similarly, for this other value, that is what will be the property for the permittivity, that is 0.02, and the apparent opening sign 0.6, maximum average roll value, and ultraviolet stability retained strength, that is 50% after 500 hour of exposure. So, this is case 2, we talk about this separation, and this is a mild serviceability condition. Next is the severe serviceability condition. So, graph strength at greater than equal to 1400 Newton, strain seam strength greater than equal to 1200 Newton, tear strength greater than equal to 500 Newton, puncture strength greater than equal to 500 Newton, brush strength greater than equal to 3500 kilopascal, permittivity greater than equal to 0.02 per second, apparent opening size AOS less than equal to 0.6 millimeter, maximum average roll value, and UV stability greater than 50% of the graph tensile strength value, that is 1400 Newton, is equal to greater than 700 Newton after 500 hour of exposure. So, you can have this value from the table 1 and 3, it is in severity condition. So, this is the severity condition, we are taking this value for all graph strength, shear strength, and puncture strength, brush strength, and this value from table 3, what will be the permittivity, what should be the apparent opening size, and what will be the ultraviolet stability of the retained soil. So, we are having these values. So, this is way we solve this problem using the ASTO specification. Next, we will talk about the sustainability using geosynthetics material, and why the question that sustainability, because the environmental sustainability of the economic growth, how the economy can grow using the geosynthetic system, what is the meet that essential requirement. We require drinking water, we require sanitation, we require health care. So, how we can solve this kind of the problem, and how we can alleviate the property issue in a sustainable manner, and also ensure that effective use of the natural resources. So, we have to be taken care for the natural resources, and how renewable energy can be also that used, how we can green rural development can stimulate the economic, in which that we can create the employ, we can strengthen the climatic resiliency. We can also go for the green business. What kind of the green business? Such as generate the renewable energy and the green product, and also you can produce the different types of environmental friendly construction material, which you can produce from the waste material, and you can make use of this. And also sustainable agriculture based livelihood. If you do the construction for the road, and you can grow the mangrove fruits, and you can make a greenery, and also in the flower. So, it is always you can sustain yourself, you can renew, how you can generate the money, and people can generate and they can sustain. Also, environmental challenge can put constraint on the attention of the development goal. So what is that sustainable infrastructure development need of today? So how the sustainability using geosynthetics, what do you mean by sustainability? So sustainability means to enjoy the better quality of life and satisfy the basic needs. The goal is to focus on the following area. We need protect the environment and the resources, climate change and energy, production and consumption. Nowadays it is utmost important to save energy and material consumption and reduce the emission of global warming greenhouse gases like methane, carbon dioxide in geotechnical, transportation, hydraulic, coastal and mining engineering for sustainable development around the world. So we need to save the energy. So sustainable development is not only saving energy and the material, but also protect the natural resources, economy and society worldwide. Why recent model development is not sustainable? Because we are living beyond our means. So what we use in the traditional material? We use huge quantity of sand and gravel for different infrastructure application. We use clay, we use huge quantity of concrete and the steel, and we use this kind of the traditional material in different infrastructure. I am just showing it here some of the infrastructure and how the geosynthetics can help to reduce the energy, how you can save the money, how you can save the time, how you can make use of the sustainable manner. So we are focusing here only infrastructure like slope and erosion, hardening, road, reflection cracking and mechanically stabilized earth wall, that is MSE, and the landfill. So in the construction industry, huge quantity of soil mass are needed for excavation, transportation and installation on the project site. You don't know huge quantity, we have to excavate and then you transport and then you have to putting to the installation site, either it is filling up or any other purpose, or huge quantity of carbon dioxide footprint emitted during the construction of various infrastructure using traditional material or system. Nowadays an effort has been made to use sustainable material named as geosynthetics. Now question comes, what is geosynthetics? Very simple definition of geosynthetics means geo means soil, synthetics means fabric, that means the combination made of soil and the fabric, that is a composite material, is called geosynthetics. Now how can you compare the geosynthetics with the traditional material? You can see we use huge quantity of the steel and the concrete for the construction of various infrastructure in India and around the world. So alternative to this traditional material, we can use the Geogrid material. So both the material will act as a reinforcement. So we talked about earlier the design is based on the reinforcement function. So instead of using the steel, concrete, so Geogrid can be used as a reinforcement. For example, we wanted to construct a reinforced concrete retaining wall. So we use huge quantity of the steel, cement, and alternative to that we can simply use the Geogrid material and soil as a backfill material. So we can save lot of money and also time. Also in terms of energy, I will show that how you can save the energy, how it is sustainable manner you can construct the defined types of the infrastructure. Next is the drainage function. Most of the cases we use the gravel, sand as a drainage material, that is the traditional material. We use in the different project gravel, sand as a drainage material, and to its thickness also vary 400, 500 millimeter kind of the thickness. So you need to transport that all kind of the material to the project site. So you have to spend a lot of money for this. You have to excavate, you have to break, you have to make the proper gradation. So alternative to the traditional material like gravel and the sand, we can use the prefabricated geosynthetics material like GeoNet and the geocomposite, and this material is very high flow capacity, so it can solve the drainage problem. It is also economical and it is also clogging free. So you can use this kind of the material like GeoNet and geocomposite alternative to the sand and gravel for the drainage structure. So this is the second function as a drainage. Barrier function. You can see that huge quantity of clay. So instead of compacted clay liner, you can use the geomembrane, and geosynthetic clay liner can be used as a barrier. For example, we use in the landfill, dam, canal, reservoir. As I mentioned that if you construct a landfill, so traditional material we use huge quantity of clay and compacted it. It varies from 400 millimeter to 1500 millimeter. Alternative to that kind of the thickness of the compacted clay liner, so you can simply use geomembrane or geosynthetic clay liner. This is also impermeable material, and geomembrane whose thickness may be 100.5 millimeter to 2 millimeter, 0.75 millimeter or 2.5 millimeter. So you can compare in terms of the thickness of compacted clay liner to the thickness of the geomembrane. In case of alternative to the geomembrane, you can use also geosynthetic clay liner, which is made of bentonite and laminated with the woven and non-woven geotextile material, and whose thickness may be 4.5 millimeter or 5.5 millimeter. And whenever the geosynthetic clay liner will come in contact with water, it swell and it act as a barrier. So you can use this kind of the product, and huge quantity of the bentonite also is available in India. So this material can act as a barrier. So barrier is one of the function. Now look at this slide as a separation function. You can say traditional method, you have on the top of the foundation soil you are constructing the embankment. Sometimes you go for the improvement of the ground by using the sanding, piling, or any stabilization system or any stone column system. So you do not need, if you adopt the alternative system, you fill up with the good quality of the graded material for the construction of embankment in the traditional material. Alternative to this system, you can see the right hand side that you can place say one layer of this synthetic material, and on the top of that you can place the geofoam. You can have it in the form of block or in the form of cellular type of the geofoam, and you can place, it is a very super light material, you just simply place it, and on the slope side you can provide with the geomembrane, and you can fill up with the soil, you can say grass can grow, and on the top of that road you can provide with the asphalt overlay. So it is a very, very simple construction. You do not need any kind of the excavation, and the design is very simple, and the design also is based on the density of the geofoam, and also what will be the thickness of the geofoam, and what will be their different mechanical and the chemical and also the environmental property. Here the geofoam act as a separation function. So how geosynthetics can help to reduce the carbon print? This is very important to us. We are talking about so many sustainable, renewable energy, how we can survive in this earth. So how we can reduction of significant amount of carbon dioxide in civil engineering project by adopting appropriate use of intelligent material like geosynthetics. So application of sustainable geosynthetics in infrastructure. I will show you some slide where you can see that how we can use, how you can save the energy. For example, that in case of slope or erosion control related problem, if it is a road and mechanically stabilized wall at landfill site. This is slope or erosion control problem. This is sustainability comparison for the 3 alternative urbaning. This is Geomembrane 2011. Here you can see that for the slope or erosion control, you may go for the roller compaction concrete. This is what is going on, or you can go for the articulated concrete block, which is called the ACB, and this is the alternative, that is HPTRM, which is called the high performance top reinforcement mat. So you can see that this RCC, ACB or HPTRM, that is ton carbon dioxide per years. So you can see that concrete, this is only material only, concrete, if for RCC you can say 0.0941 ton carbon dioxide per years. ACB articulated concrete block is 0.041, here you do not need any concrete. Steel, fiber or cable, for RCC it is 0.0097 ton carbon dioxide per years, and for articulated concrete block or ACB 0.0446, and you do not need for HPTRM. If you use geotextile, it is 0.005 ton carbon dioxide per year. HPTRM you do not need, HPTRM you need only 0.0015 ton carbon dioxide per year. Topsoil that you require for ACB 0.0023 and also for HPTRM you require 0.0023, and seeding you require for ACB 0.00028, this also for HPTRM 0.00028. So diesel fuel, that is delivery only. So if you deliver only diesel fuel, your for RCC, that is roller compacted concrete, you require 0.449 ton carbon dioxide per year. For the ACB articulated concrete block you require 0.505. On the other hand, for the HPTRM or high performance trap reinforcement mat you require only 0.082 ton carbon dioxide per year. So total carbon dioxide footprint in case of RCC 0.533 ton carbon dioxide per year, and ACB articulated concrete block you require 0.594 ton carbon dioxide per year, and for HPTRM, that means high performance trap reinforcement mat, you require only 0.087 ton carbon dioxide per year. So what we have observed here, that HPTRM or the high performance trap reinforcement mat is green and more eco-friendly compared to the roller compacted concrete or the articulated concrete block. So next, if we consider a road project, what incorporated geotextile for reflective cracking. So you can saving the aggregate and asphalt concrete. This is by Miner and Davis 2011. This is the existing AC, that is your 50 millimeter, 75 millimeter and 100 millimeter, and then proposed AC thickness millimeter 112.5 millimeter, 112.5 millimeter, 112.5 millimeter. Every year you keep on putting the asphalt overlay on the existing AC. So if you use that geosynthetics material, so proposed AC thickness with geotextile, you can see how you can reduce, that is 62.5 millimeter, 75 millimeter, 81.25 millimeter. Okay, if you subtract from this to this, you can have this. So reduction in AC thickness will be this minus this is 50, and this minus this is 37.5, and this minus this is 31.25. So how the thickness can be reduced drastically, and equally you look at the asphalt cement saving per lane mile in kilonewton. This is very expensive asphalt cement saving. So you can see that here you can save 330 kilonewton, 290 and 240. So reduction in hot mix asphalt concrete, which you call the HMAC. So you can save lot of energy, you can save lot of, it's like a apple to orange, this is a age old apple to orange comparison. Now we'll discuss this MAC burn at the landfill. So here is the landfill, that all waste containment, it has a slope that 3 vertical, 1 vertical to 3 horizontal, and this is 8 meter, here this 3 horizontal to 1 vertical, and height is about the 10 meter, and this is all unreinforced, and this is 1 vertical to 3 horizontal. So how you can minimize this, how you can save the energy? So you can provide with the multi-layer of the reinforcement, and also you can reduce the slope vertical to horizontal is 2:1. So, you can minimize, and this also you can see, this is the 1 vertical to 3 horizontal, this is 1 vertical, vertical to 3 horizontal. So, you can construct, even then you can construct this reinforced wall here. So, you can save this land. Now, if you wanted to increase, vertical increase in the landfill capacity, so you can increase the landfill capacity by introducing this geosynthetics material. So, you can make a BAM, mechanically stabilized earth BAM here, and you can provide, this is the landfill. So, you can provide this liner, either geomembrane liner, impermeable material, and this can also increase, that will vertical increase in the, that will increase also the landfill capacity. So, you are providing the space to feed up the all kind of the waste material into the landfill by vertical increase in the landfill system. So, you can increase the landfill and you can provide here with the mechanically stabilized earth BAM system. So, you can reduce that, reduce the slope, or you can excavate, you can make a steeper slope, or you can make a even the 90-degree, that is reinforced soil retaining wall. Now, you can see this, that mechanically stabilized earth BAM at landfill. This is a Baron and Lewis 2011, and this is the traditional method, that is 3 horizontal to 1 vertical. You can see mechanically stabilized earth BAM, this is 1 horizontal to 2 vertical. Then how much you are saving? So, if you use compacted selected fill, so traditional method you require 1826 kg per meter square. If you use mechanically stabilized earth BAM with 1 horizontal 2 vertical, your requirement is 1174.1 kg per meter square. That means you are saving 651.9 kg per meter square. Now, look at the transportation. That means you require import of the selected fill. All the time you cannot have the material on the spot. So, you require to import of the selected fill, that you require transportation, and that for traditional material you require 177 kg per meter square, whereas in case of MSC BAM with 1 horizontal to vertical you require 114 kg per meter square. So, you can see the saving is about 63 kg per meter square. Or if you use high density polyethylene, that means HDPE or polypropylene phase wrapping, then for the mechanically stabilized earth BAM 1 horizontal to 2 vertical is required only 47 kg per meter square. If you use maturing and the shipping for mechanically stabilized earth BAM, sometimes you require to transport this kind of the material on the side, that means high density polyethylene or polypropylene or the Geogrid material or the geotextile material on the side, you require transportation. This is very light material compared to the soil. So, this is for mechanically stabilized earth BAM you require only 4 kg per meter square. So, look at this, what will be the total carbon dioxide footprint if you adopt the traditional method. If you adopt traditional method, you can see that total carbon dioxide footprint is 2033 kg per meter square. Whereas, if you use mechanically stabilized earth BAM with the 1 horizontal to 2 vertical, and it is 1339 kg per meter square. So, you are saving about 714.9 kg per meter square. You look at that how the carbon footprint reduced when you use the geosynthetics material. So, this is some of the example I have just addressed, that how this in case of the erosion control or the slope, in case of mechanically reinforced earth wall or the landfill, etc. Now, this is one study I just mentioned. The most of the cases that sometimes we find we want to construct these reinforced soil retaining wall, mechanically stabilized reinforced soil retaining wall, and the both side of the highway we provide with the geogrid material and construct this mechanically stabilized earth wall. But sometimes this design is slightly different. They extend it and then fill up with the filling material, and then they put the multi-layer of reinforcement here or here. But if you think about the material collection, dumping, compaction, and with respect to this structure. So, this is very typical structure. They say that this will be the much more cheaper because this number of the reinforcement layer can be reduced. But if you think in terms of the energy or carbon dioxide footprint, so it seems to be something different. So, that I think that some study is needed in India in this related area. Now, I said that how this material, traditional material which act as a reinforcement material, steel and concrete, alternative the geogrid material, you can see that 542 tons carbon dioxide if you use this kind of the material, steel and concrete, whereas if you use the geogrid material, you can see 101 ton carbon dioxide. So, this most of the time we use in our many mechanically stabilized reinforced soil wall and the slope. So, you think that if you adopt this conventional method, what will be the quantity of carbon dioxide? 542 ton. On the other hand, if you adopt the alternative material like geogrid, so your carbon dioxide is 101 ton. So, you can save. And also for the filtration, drainage and erosion control function, we use the most of the time gravel, armor, sand. Alternative to the alternative method is geonet and the geocomposite material. So, this erosion control road, dam and also retaining wall we can adopt for the alternative system, and it can be reduce the carbon footprint. Next, in barrier function, we use the clay and the alternative the geomembrane or the geosynthetics clay liner. You can see here 21,000 truck load of clay and gravel is equivalent to only 165 truck load of geosynthetics clay liner and geomembrane. This is Mahbubage ETL 2011. You think about that, for example, if you want to construct a landfill and as a barrier, any place you go for the dam construction, you go for the canal construction, you go for the reservoir construction, you think that 21,000 truck load you require of clay and the gravel for the construction with the conventional material. On the other hand, if you simply use the 165 truck load of geosynthetic clay liner and geomembrane, so you can save lot of energy. So, you can reduce huge quantity of carbon footprint, and this geomembrane is very thin, as I say 0.75, 1.5 or 2 millimeter or the 2.5 millimeter, and it is very easy to transport, it is very lighter material. So, this kind of the application barrier function as a barrier function in the case of the landfill dam, canal and the reservoir. So, also separation function instead of the conventional material, so he can adopt the geofoam material which will be the very lighter, and also he can save lot of carbon dioxide. So, we say transportation, waste, power and infrastructure are mainly the reason for carbon emission. If we do not control or take care of carbon footprint, our life will be miserable and unsuitable for living in the planet in foreseeable future. Every human has to be cautious about their way of living in the planet. By 2030, it is necessary to decarbonize the world by 90% for making the planet sustainable. Sustainability is like a FEST, FEST, that is financial, environmental, social and transparency. So, we need reduced waste and emission, save energy, go green and adopt green technology. So, what we have covered, I think you have understood how we can save the energy, otherwise what will happen in the world in future. So, everybody has to be cautious about this, what kind of material should use, how he can to save the planet, how he can go for the green technology which he can do for the lot of renewable energy, and he can sustain yourself. So, you require proper kind of the management, proper kind of the planning. So, in order that people can sustain in their own renewable resources. Please let us hear from you any question. Thanks for listening.